Hello and welcome to this episode of AI GovCast. I'm Sylvia Oakland, staff writer with GovCIO Media and Research, and today I'm joined with Gina Tourassi from Oak Ridge National Laboratory, and we're here at the AI+Expo. Gina, thank you so much for joining me today.
Sylvia, thank you very much. Very happy to be here.
Yeah, I was able to attend your session, and I had some really great notes. You had some really great quotes in there that I loved. And one thing that you said was, we're at a genuine inflection point for science. And I was wondering if you could elaborate on that and explain why are we here? What's going on?
Sure. So, what we have experienced over the past several decades, we've seen the scientific process um, and scientific discovery be very much dependent on major leaps in computing, building bigger and better computing systems that allow us to tackle problems that we were unable to tackle before, or experimental instruments that are extremely capable. And the shift, and at the same time, I would say that in the past 2 decades, for sure, with the data tsunami that we have experienced and the digital revolution, a lot of data intensive activities that are happening across all scientific domains. What has been the inflection point, I believe, in the past few years has been the renaissance of artificial intelligence we have experienced, and particularly with agentic AI in the past 4 or 5 years, the large language models and now the agentic AI. We're seeing now artificial intelligence playing an important role orchestrating all of these unique capabilities and resources in a more creative way than we have before. So suddenly we're taking the same scientific method that we've been implementing for centuries in terms of the ideation, hypothesis, generation, designing experiments, collecting data, analyzing the data, leading to insight or revising our thinking, now happening in a completely different way and with more closed loops. So suddenly, artificial intelligence allows us to have what I called a real-time learning system. So that is the tipping point. The scientific method hasn't changed. The scientific process is the one that's changing and opening new doors for our community.
And that's what you mean when we hear the accelerating scientific
Exactly,
discovery.
exactly.
Okay.
Because now we have these loops in the process, real-time learning, real-time adjustment of our thinking, real-time adjustment of the experiment, instead of the linear process that we've been following, for decades, from beginning to the end, back to the experiment again.
Yeah, it's a much more fluid process. I
Exactly,
loved the way
exactly.
that you explained that. And that's when we kind of get into, you also mentioned making science more interoperable. And I'd like to talk about that on the technical side, looking at some of the data and some of the again, those technical aspects. You're working with the American Science Cloud, and that really is pulling all of this scientific data together. So do you mind explaining how the American Science Cloud fits into the Genesis mission?
Sure, yes. So the Genesis mission has this aspirational goal, right? Accelerating scientific discovery by pulling all of these pieces together. It's not just the data, it's all of the assets, the important assets that allow us to accelerate, to do our science. As I said, the big computers, the experimental instruments, the data, the AI models these days, all of these assets are completely fragmented because they are distributed across the ecosystem. Just look at the DOE 17 labs. All of us have unique capabilities. At the Oak Ridge National Lab, we have the supercomputer, Frontier supercomputer, we have the spallation neutron source, we have the Center for Nanophase Materials, Advanced Manufacturing, right? Similar critical assets exist in other labs, other supercomputers, light sources, and so on. What is the experience from a scientist perspective? They need access to these resources and they have to navigate these different labs because each one of those labs is a different ecosystem. So they will need to get access to the supercomputer here, to a light source over there, to the manufacturing over there. What the American Science Cloud does is to build that infrastructure that pulls these resources into a unified ecosystem and offers what we call the one entry, the single entry. So then we enable the scientists to be able to navigate that without knowing what's happening behind it, where exactly that resource resides. So this is the first element, and that's why we consider the American Science Cloud a building block in the Genesis mission, because it pulls all of these resources on the open science side, the Office of Science, and coordinates them. We do not, as I like to say and emphasize, we do not standardize science. We do not dictate how science is done. What we're trying to do is to make science as interoperable as possible. So people do not reinvent, the scientists do not reinvent pieces that could be used, reused effectively across the ecosystem. So data sets are easily findable, movable, allocation of compute resources is easier, allocation of time for the different experiments, all of that becomes frictionless.
Yeah, I mean, I when I think about Secretary Wright said yesterday in his keynote, his fireside chat, that we're looking at the way the world works, and I think we've studied the world in its siloed ways, but now we're at a point, like you said, this inflection point where we are studying things in its entirety, in that whole ecosystem, looking at how things interact with one another on a closer level and seeing how we can harness that. Like, there's a lot of conversation around the fusion energy, how we can harness these different technologies, these different powers to really accelerate what we want to achieve. And I think that leads me to then, you talked about it a little bit, this shared vision of getting everyone kind of on the same page. It's a technical challenge, but it's also a cultural one. So do you mind just kind of painting that picture of what that cultural challenge looks like, and maybe some things you're doing at Oak Ridge to try and ease it?
Yeah, no, you're absolutely right. Often in science, we tend to focus a lot on the scientific, the technical challenges, but you're absolutely right. We soon realize that administrative challenges, policy challenges, cultural challenges are as difficult or sometimes more difficult to navigate. The scientists are notorious for wanting to get to the output and having control of their destiny, and therefore developing bespoke solutions, right? Because they need to get to the answer. And that's what's happening across the different scientific domains. Now science has become more complex than ever before because we keep challenging ourselves, and we have realized that the most exciting scientific discoveries tend to sit at the interface of the scientific domains that have different bespoke solutions and domains that have different cultures. So this is where now we're seeing that we cannot ignore the administrative and policy controls. American Science Cloud is doing that by saying we need to develop the federated ID. The scientist needs to have one federated ID that applies across all of these resources instead of a different one, because each one of us that manage facilities, we have our way of thinking and executing policies and all of these things. And at the same time, the scientists also need to recognize that they solve their problem in their domain. They have created this amazing tool that could be easily extended somewhere else, but the other scientific community is not aware of the solution, and they are starting from scratch. By creating this ecosystem where all of these solutions are present, and we think of the scientific workflows not as a one solution but as a modular approach that is composable with components. These components are available to everyone and visible, findable by everyone. We are helping the scientific community spend less time reinventing the wheel in some pieces, and more time on the intellectual aspect of that. So that is the part of that cultural shift. Genesis mission exposed these challenges that we all knew, but exposed these challenges to us um, in a brutal way, right? Because Genesis mission started in October. The DOE labs have been coordinating around the big AI vision for several years. We knew our challenges before the Genesis mission. Because artificial intelligence is nothing new, right? It's been going on for decades. We have been through the different stages, different seasons of artificial intelligence. Communities have been implementing AI technologies. But what the Genesis mission exposed to us that indeed, if we want to run as fast and to meet this grand challenge of, accelerating this productivity by a factor of 2 in the next how many years, we need to acknowledge that we need to change culturally and we need to lean in. It is not, I have the solution and everybody else needs to embrace the solution. Let's see what we're bringing to the table and how we can pull these pieces together in the most effective way. The American Science Cloud does not dictate the solution, it creates that abstraction layer and the necessary APIs to access the solutions that are available and to stitch scientific workflows for the community. We are designing the American Science Cloud based on scientific workflows that are very prevalent across our scientific communities. But we know the world is changing very fast. So we need to have an infrastructure that is agile enough to support new scientific workflows that are not prevalent right now, but they will emerge through these grand challenges that the Department of Energy is tackling across the scientific domains. What you see discussed here, or what you see with the demos.
Yeah, it's so exciting. The 26 challenges. I've been those ones that have been announced since late February, early March, and just looking at them, and I'm excited to see kind of that next step. And speaking of, Oak Ridge has some pretty big news coming up here in 2026 with Lux, correct? And do you mind talking about what? I mean, we're almost halfway through the year, so what does that look like when 2027 comes around? Where can we see Oak Ridge and its supercomputing capabilities?
So your question goes back to, yes, we want to do this great science. Yes, we are going to leverage frontier AI models, working with industry or developing them from scratch with our scientific data. Yes, but as we all know, AI is compute and data hungry. So on the compute side, we have tremendous compute resources across the DOE system. These compute resources are already overcommitted, and now we have a new set of challenges coming in with lots of demands. So that goes back to, do we have enough AI capacity to support the rapid increase in demand that we're expecting from these grand challenge teams? Lux is one of the solutions that is presented. Similar solutions are coming out from the Archon laboratory and from the broader ecosystem with partnerships with cloud providers. But specifically for Lux is a public-private partnership with Oak Ridge and AMD. It's a system that is starting to be delivered in the end of May, and the completion of the delivery will be beginning of July. So when the first teams are starting to be onboarded, they will be on Lux in addition to the other resources that are available at the ecosystem. The other resources, as I said, they have a certain user community, allocations in certain ways with competitive proposals that our broader user community from academia and industry, they are very much aware of our resources. Lux will be dedicated to the Genesis mission platform
Wow.
challenges.
Yeah. So all of that compute, all of that power will be helping advance the other labs sort of challenge problems.
Exactly. As I said, it's a public-private partnership, so absolutely AMD has a big component because we're not uh, buying the system; it is leasing the system, and we're leasing a very big part of that because it's going to be at the Oak Ridge National Lab. It will be in our user facility. So we're providing the data, the space, the power, the cooling. We are operating the system with the OLCF, the Oak Ridge Leadership Computing Facility model of operation, and a big part will be dedicated to the Genesis mission and the ability to burst on the full system as demand.
I've heard so much about how this really is a huge public and private partnership, and I think that the way that you just explained that is it sums it up wonderfully, right? It is this truly fluid exchange of information and resources to help really, like you said, advance some of these really big problems that I didn't ever think would be solved in my lifetime, but it's looking like we're making some really big progress and some good headway.
Yeah, the way I like to say it, it's a true co-investment model from two entities that they are like-minded in terms of science and mission.
Right. And that's what, we're getting back to this one DOE, this one through line of advancing scientific discovery. We've heard that through and throughout a lot of the talks here at the AI Plus Expo. So, Gina, thank you so much for joining me on the show. I really appreciate your time.
Thank you, Sylvia. Appreciate it.